Hey everyone, this will be just a pretty quick video just showing off some of the newer stuff I've worked on over the past month. So let's get right into it. Let's load up the editor here. So this will be the first thing you see when you load it up. It's a blank editor, no projects loaded. Right here there's a quick drop down bar that'll show all the projects that are in the project directory that you can load from. I think I showed this in the last video, so this isn't new stuff. So what I got done was finalizing the build loop, which means that you could load up into here with nothing, start a new project, start working in it, save out scenes, all that kind of stuff, and then make a finalized build where everything's packaged together and it's essentially you could package it all up and it's ready to be deployed, quote unquote. So I just want to kind of walk through that process and just going to show that off and then talk about some smaller more specific things that I've worked on. So again, this is the first thing you see. It's blank, there's nothing loaded. So what we'll do is create a new project. And again, none of this is finalized. All this UI and UX is really kind of crap. So I'd really like to take some time and really work on the editor interface. But that's going to take a while to get that to be nice. That's an ongoing process. And I haven't even started looking at that. This is all just placeholder for the most part. But anyway, let's kind of make something here. So our new test project. Okay, so what I used to do whenever you clicked create project is it would just make an out call to the system and it would run this build. So let me show you here. So it would grab from some templates, copy these all into a new project directory, and then just start running a bunch of bat files. It still does that, but what it does for you now, I'll click on this here, it still copies all this stuff and runs the CMake to build the new directory, but at the same time it also compiles the project. The reason I did that is before it would just open up the solution and then you would have to explicitly compile the project. And you had to do that so that the DLL would be loaded into the application or into the editor so then you can actually start running things. Now I do that for you, so you don't really have to come in here at the very start if you don't need to. It's been loaded, so now I can just go ahead and start playing. But you'll notice there's nothing here. We don't actually have a scene loaded up. So I've made a create menu up here. This is just some really basic stuff. All it does is create some new entities or some, basically now it's just entities, and adds components to them. So something like this cube component here, or this cube object, it'll create an entity with a graphics component with a cube mesh. It also has a rigid body component on it with a cube shape, or a box shape rather. And then some lights, a sphere, and then finally a scene. So if we click scene here, we'll now have a new scene available to us. So let's load that up. We've now loaded the new scene. We can save this, play it. Again, there's nothing in here, but now we can start actually populating it with entities. So let's throw a cube into the scene. We got this guy. So you'll notice one of the first new things is some transform widgets. So probably one of the first things I started working on was the ability to be able to add in new entities into a scene and then be able to manipulate them. So the translation widget here works both in local space and world space. And it works very similar to the way something like Unreal would or Unity. You have shared axis widgets, so these planes here, so you can drag along shared axes. You also have individual axes, which you can drag and move things around. And the way that I got this working, which I can show you in one of the frame buffers here, there they are. So everything writes out to an object ID now. Basically what you do is every single renderable gets a static ID, which typically is just tied to the entity's ID. Get that, and then you convert that into an RGB value, pass that up to a shader, and then I write that out through my GBuffer. And then what I do is whenever I'm interacting in a scene or the mouse is clicking on something, I read back from that buffer, reconstruct the ID, and then I'm able to grab the entity that I'm actually interacting with. So what that means is that I have pixel perfect precision with selecting objects, and also with manipulating this transform widget here. And it works pretty well. There are some instances where if the widget is too small on screen, since it is pixel perfect, it can be kind of difficult to navigate this thing. So I might come up with a different way of handling the widgets themselves. These might actually just be distance to line approximations or something like that, which is pretty similar or pretty standard for how a lot of other systems or other engines do something like this. But for now, it's working fine enough for me. It's not such a huge annoyance. Let's see, so there's the transform widget. We also have a scale widget. This is locked to world space only, which actually might make more sense if I show the rotation widget first to talk about spaces. So right now I'm in world space. That's what it starts up in. I can start rotating objects here. Again, these rotate around the individual axes. There are different ways to handle rotations for different types of widgets. Every single editor that I've ever looked at does it differently. Unreal does it to where if you continue to scroll out, then what they do is it's almost like you're scrolling along the tangent, so you're pulling some kind of torque for the object, and so it'll just continue to rotate along that. I tried implementing that, and I could never get it to work exactly the way I wanted to, so I want to go back when I have time and maybe investigate why that was working kind of oddly. Right now what I do is I capture a delta and then restore or retransform the delta each frame. So I take a delta, say okay, I clicked in this plane, and then I start dragging along, and then it resets the delta, and then I add that to the previous transformation. So what that means is that I can actually fully go around the entire plane. So you imagine if there's a line being dragged out from the center here, then I'm just pulling along that line. That works well for most transformations. However, you can probably already notice there's a problem with that. If I'm really orthogonal to a plane, it's really difficult to actually wrap around. This is what Godot does. Theirs is actually more finicky than this, but mine has the same problems, and that's why I would like to go to something like Unreal or Unity does. I just need to take the time to figure out the rotations correctly. Yeah, so again, I can go between different spaces here. This is in world space, so you notice that the widget itself is not rotating with the object. It's not transforming to it. But then I can go back to local space, so now it's actually transforming with the object. That works for all the other widgets as well. You notice that if I go back and forth between local and world, I can move along the different spaces here. And then the last one here is the scale widget. It only works in local space. The reason for that is if you're trying to scale something, you don't want to do any kind of destructive transformations on it. Which means that if it's in world space, there's a possibility that I could actually end up shearing some of the mesh edges or the mesh vertices. And then if you shear it, there's no way to get back. So you typically lock it to something in local space. That way you only work along the relative axes here. When I was looking at different implementations, most engines tend to do this and get it correct. Godot doesn't, which is strange. Hopefully they fix that. Unless, I hope it's not intended. But yeah, anyway, so we can do some easy transformations here. And this all works pretty well. It also is able to scale uniformly here. That seems to work pretty well. Yeah, and that also works for this as well. There's a uniform transformation along all axes. I don't have one for this yet. This one's a little more tricky. You're actually rotating around an entire sphere. But again, one of the things that I would like to eventually add. Okay, so let's delete this guy and then get a new cube out in here. One that has base transformation. Again, I can come over here and local transform and also manipulate this stuff. Okay. So again, another thing I said I worked on is physics. So as soon as you add something like a cube or a sphere, it attaches a rigid body component. It has pretty much all the basic properties that you would expect to have. Angular dampening, mass. If it has no mass, then it's a static object. If it has mass and it's not a kinematic object, then it will have gravity applied to it. You can adjust the gravity for each object. This is all using bullet physics, which it's worked fairly well so far for me. Down here we can adjust shape types. When you do that, it constructs a new collision shape for you. Let's see. Yeah, there we go. This one here. This one actually probably needs to go away since this is the only one you're being used. But if I sit here and play now, okay, so the way the editor works is, again, it ticks its own application. And right now each component has a life cycle tick to it. If we go to something like the physics component, oops, rigid body, not physics. Maybe the graphics component is probably. So for all components, they have a life cycle. So a tick state, essentially. It just determines whether or not it's going to be ticked whenever the game is paused, whenever it's shut down. You know, when am I going to update this component? That's good for certain things. For certain things, you want to be ticked always. So whenever the application is paused, whenever the editor is running, and then there are certain things where you want it to tick only whenever the application is running. Maybe only when the editor is running. You know, maybe only when the application is paused. So this allows me to do that. So for the graphics component here, which is actually rendering the mesh, it always gets ticked. For something like the rigid body component, its default state is not changed, so it will only be ticked whenever the application is running. So what that means is that in here, the physics subsystem is not actually ticking the rigid body component here. It's not until I actually hit play that you notice that physics actually starts getting applied to this. So that's a pretty important distinction. And it makes editing these things really simple. I don't have to worry about physics actually interacting with this thing while I'm setting up scenes. You know, it's pretty necessary. Okay, so let's set up a quick scene here. So got this guy, we'll set it to 0 mass. Restitution is kind of his bounciness, so we'll set that up. And then let's drop a sphere in here. I'm gonna shrink him down a bit. Throw him up, and then make his restitution kind of high. Now if I hit play, you'll notice it starts kind of bouncing a little bit. Alright. Let's see, what else did I add here? I'm trying to go through all the different stuff that I did, and then show the finalized build process. Adding new components is actually pretty simple. Before this wasn't possible because I wasn't compiling it for you inside of the engine. Now you notice that this compile and build step are up here. So what I do is, whenever you want to add a new component, let's just show that. So add new component. It brings up this dialog here for you. So I don't know. Naming stuff is always so difficult for me. Random test component. So if I try to, I'll show a couple things. If I try to create something that already exists, you'll get this notification says it already exists, so we can't do that. If I try to do something that's not a valid C++ name, since that's what this thing is creating for you, it'll tell you that. So you try to check certain things. You know, obviously there are things that I've probably missed since this is really thrown together really quickly just to be able to test this stuff. But let's do a valid name, so we create that, so it starts creating it. So what this does is it generates code based on a template. So if we look in here, we actually have a new header and CPP file. And then what it does is it recompiles that into the project. That way it's actually able to reload the DLL and then now add this component. So now we notice that it's attached to our component here. If we go, or it's attached to our entity, if we go into the project solution, we will notice that, let's go to the source. Yeah, so we have our new component in here. This is what a base component looks like, or this is what the template gives you. So each component in its life cycle, it has an initialization, has a start, update, and a shutdown. What happens is whenever you create a component, or whenever you create an entity, the entity manager adds it to an add list. And on the next frame, it actually adds those into the active entity list. The reason for doing that is that if you add entities inside of a loop into the active entity list, you end up invalidating that vector. So I need to push it back to a new list, and on the next frame, it actually adds it. And then what it does is after it adds it, any components that have been created, those are added to two different lists. It's added to a component needs initialization list, and also a component needs a start list. And then what happens is, depending on the life cycle of the component, depending on when it gets ticked, it'll get initialized whenever the application is running. So this gets called. All of the components that need initialization, they go through and they get called. And then after that, all the start gets called. The reason you have two different ones is that if you have some components on an entity that need to reference other components that entity might have, you have to do it in a specific order. So if I have component A that references component B, if component B isn't initialized yet, then component A has no way of getting that information that it needs to initialize itself. So typically what you do is you have this initialization, everything initializes itself, and then you have a start where everything does post-initialization, essentially, where it's able to reference other components. So that out of the way, in the CPP file, this is also really simple. All it does is just does nothing in these components or these functions yet for you. But again, you have initialize and start there. Update, this gets called every tick, and then shutdown, right? So let's go ahead and do just a few things here. So we'll just add some print statements here just to show that these are working. And we'll call it what it is. Cool. Okay, so I have two options for recompiling this. I can compile it here, or I can compile it in the engine. Hit this guy. Again, it does the same compilation, recompiles it, and then it reloads the DLL. So let's do that real quick. I've noticed that because this is making system calls, this tends to run a little slower sometimes. I need to look at that because it can get kind of annoying. There we go. So we have this guy. Now if we play, then you see we've put in our print statements, which are spelled incorrectly, I've noticed. Initializing. Did I spell it right? Yeah, good. And also they don't have any line breaks. So add those in there, recompile it. Wait for that to get done. Take a sip of my coffee. And done. And then when we play, there we go. So it does the initialization of it, and then it starts it. Yep, pretty straightforward, pretty simple. I think that might be it in terms of the build process. So last step is, say you've done all the work, now you've set up your scene, you've created everything, you tested it out, great. And you want to finally build it. So what you'll do is you'll come up here and hit build, and it'll actually build out the process for you. Before I do that, there is one caveat, and that is that we don't have a camera in our scene, so we'll add that next. But also, I don't have any kind of scene management yet. I am thinking about the best way to handle this, but basically the problem is that whenever this loads up, it's trying to load a default scene, but it doesn't have one. So it loads an empty scene with nothing in it. So what we have to do is explicitly give it the scene that we want to load. So whenever the engine loads up, it loads up the application, and then it initializes the application. So what I'll do here, just a really quick short hack, is give it the scene that we're actually looking to load. Okay. Again, you won't have to do this explicitly. What I intend to do is have some kind of scene management, and then inside of the project settings, just like Unreal or Unity, you just give it a default scene, or you say this is the starting scene, and then you handle the scene management yourself after that, right? So doing scene transitions and stuff. But in terms of actually knowing which scene to load up, you would tell that inside of project settings. Okay, so we also don't have a camera. So there is a camera component. So let's create an empty entity here and set it here. There is a bug right now with my rotations. So I've set a shortcut command. If you hit Control-Shift-F while you have something selected, then it sets it to the position and rotation of the editor camera. Unity does this. It's really convenient. I like it a lot. But I've noticed in doing that, I've noticed there's an issue with my rotations. I think part of that reason is going back and forth between quaternions and Euler angles. So I'm thinking what I'll do is only internally will I use quaternions, and then everything else will most likely be doing Euler angles to represent rotations, especially inside of the editor. Just makes things, I think, a little more intuitive, and probably fix some of these issues. But anyway, so on this guy, you notice you have a camera component here. So let me attach that to him. What this does is whenever that component gets initialized, it adds itself to the scene, and then it sets itself as the active camera. So you notice that now we're from the viewpoint of that particular camera. So if I bring my editor camera back over here and look at this and hit play, we're back where that camera was. You can have multiple cameras in the scene. Right now I don't have a way to be able to say at this point set, well, I do have a way to say set active camera. So you have control over that, really. It's just kind of a kludgy system, and I don't really like it because you have to explicitly say set camera, set camera. I'd like to have more like a stack-based approach where you would pop on a camera and then pop one off. I think that might be a little nicer, but I have to think about that. Same thing for input states as well, probably popping and popping off. Input states would be nice. Okay, so we have our camera set up, we have a simple scene, and now we can make a build. So if we come over here and actually click build, what this will do, if I open up our project here, so this is the project directory. If I click build over here, it's going to run through some stuff. What it does is it creates a final compiled directory, and the platform that it's building for, this will be Windows, and then it packages all the assets up that you were using for the project. So all the project-specific assets will come in here. So this is the scene that we created for that project. These are all the engine assets that are being used. And then things that haven't been cached but also need to be available there. So any of the fonts that were used, or just all the fonts, regardless if they're being used, and all of the engine jitters as well. And then what it does is it creates a quick intermediate directory. This most likely will be deleted so that it's not cluttering anything up. I just have it here so that I can debug stuff. So it creates an intermediate directory, and then it creates the final executable, and then has any DLLs that it needs to use. So I think it's pretty tiny. I mean, with this being gone, you would really just have the assets here, which is kind of nice. Yeah, so if we actually click on this guy and run it, it's now self-contained. And here's our scene that we had. So this is essentially the finalized build process working in a nutshell. And again, we have our two components, or a component doing the initializing and starting calls for us there. So let's stop that. And yeah, that's pretty much the entire process. So there's a lot of stuff to continue to work on. This isn't anywhere near feature complete. It's just the very much the starting point. A lot of stuff still needs to be cleaned up. which I will go through and make sure to start doing that. Let's see. And then a couple of small things, just to kind of make note here. I went through and finally cleaned up the GBuffer. There's no position buffer anymore. I'm now reconstructing that from depth, so that saves a lot of space. The buffers have also been reduced in size. A lot of them used to be 32-bit buffer. Now I've gotten away with doing 16-bit. Let's see. I've also gotten rid of all the alpha for majority of the buffers. Those don't need to be there in the GBuffer at all. At least not for anything I'm doing, so I've gotten rid of those. I've also fixed some issues with SSAO. SSAO was pretty horrible there for a little bit. Let me get this guy. So there was an issue going from projected, or for going from screen space to world space, and so a lot of the math was wrong, but now I've fixed it for the most part, and I think it looks a hell of a lot better. A lot of the parameters actually make sense now. They work the way that I would expect it to, so I can do a pretty large radius here, and it actually goes out from the occluded area, which is nice. You can increase the intensity, and that seems to work really well. And then also the biasing on the scale, so anything behind it, right? So this is like a depth scale. And then a lot of it's pretty apparent whenever I start adding other flat surfaces into the to the scene here. So what I was having before was any of the flat surfaces were getting really horribly self-shaded. That seems to have gone away, which is nice. That seems to have fixed that issue. I was also having an issue with the previous frame buffers, just how large they were. Anytime I got really close to an object, because of a lot of cache issues, I was dropping frames like mad. That seems to have gone away, which is good. There is still some of that slightly happening. You notice here I'm kind of going up a little bit in frame time, and as I start to back away, it starts to drop down just a bit. So there is some of that needs to be fixed, but I'll continue to work on that and continue to optimize the buffers. And then this is pretty contentious. I showed some people at work and they hate it, but I like it. I don't know. You might notice that there's a bit of motion blur here. It's been intense right now, but big reason for that is I'm not actually scaling the blur based on the delta time, and since OBS is hitting this thing pretty hard, normally this thing runs sub 4 milliseconds, which is really good. It's like 250 frames a second. Right now it's running a little under 100 milliseconds, or 100 frames a second. It's at 11 milliseconds. So you get a really huge shift in in motion blur there. It's been intense. So I've actually dropped that down a bit. Really, the reason I like it is that with it a little bit of subtlety, it does add a good amount of anti-aliasing to a scene that has a lot of aliasing, especially when you have things like, if I change this guy's graphics component, let's see, to this, and then have him bounce, let's move him out of the way, or delete him. Well, never mind. Again, nowhere near production ready. Yeah, I think I'll probably call it there. Yeah, so that's pretty much it. Other than the crash, that all kind of worked the way I would expect it to. Again, a lot of things to continue to iron out, but that's part of the process. So, thanks for watching, and hopefully I'll be able to show off some new stuff pretty soon. Alright, thanks.